This is a rate of change question, and how we recognize that is if we read the question, it will mention things that will kind of make that a bit clear. So it starts off by saying figure 2 shows the right circular cylindrical metal rod which is expanding as it is heated. So this cylindrical rod is expanding, so the x is changing. Okay, so it's a variable. Right circular meaning it's right angular, the circle to the length of the cylinder. It says here after t seconds the radius of the rod is x centimeters and the length of the rod is 5x centimeters, as we can see here. The cross-section area of the rod is increasing at a constant rate of 0.032 centimeters squared per second. Now this mention of the word rate here should give us an indication that we can obviously write down a rate of change here. So what does it say? The cross-sectional area of the rod. So this means cross-sectional area. I'll use the letter A to denote area. And since it mentions that the cross-section area is increasing at a constant rate, that means rate means over dt. So what we've got here is dA by dt. Another way of checking is by looking at the units to see if it's dimensionally correct. So for units of area, we should have centimeters squared. For units of time, we should have seconds. And centimeter squared divided by second is the same as centimeter squared per second. So the units are correct. So that's what our dA by dt is. Let's go and write down what dA by dt is there. It's equal to 0.032. Now, there's a lot more information that I need to use from this, which I haven't used. I know I wrote down A, so let's go and write down an equation for what A is. Well, we know A, which is the cross-section area, is equal to pi times radius squared, in this case pi times x squared. So there's my area. Now, there's also the mention of well, in the question, it actually talks about the surface area as well. So expanding heat after t seconds, and then the cross-section area of the, okay, so it hasn't mentioned surface area yet, but it might. Let's just keep that in mind. Let's go and see what it's asking us to find in the first part. It's asking us to find out what dx by dt is. Now, since we've got an equation involving variables a and x, I'm going to first of all differentiate this to find a derivative, dA by dx, which is equal to 2 pi x. I'll keep that there. I might need it at some point. And so I've got a derivative here. I've got another one there that I've written down. dA by dt is equal to 0.32. We'll label that number 2. And the question's asking me to find out what dx by dt is when the radius of the rod is 2 centimeters. So I'll start by writing down dx by dt, which is what we're after. dx by dt equals, I want to get something with dx on the numerator and something that involves dx in it. So can you see this equation, number 1, has dx in it, so I'm going to put that in. But instead of writing dA by dx, I'm going to write down my dx on the numerator, so it will be dx by dA. So there's my dx on the numerator. Now I want to essentially use the chain rule. So I need to times it by something where I want to get rid of this dA from the denominator. So I need to have dA on the numerator. So essentially it's that one here I can use. It will have dA by dt, that one, if I use that. So as you can see, the dAs do cancel, leaving us with dx by dt on the right hand side, as is what we want on the left hand side. So this is correct application of chain rule, and that's how we check if it's been applied correctly. Now that my equation relating each of these differentials is correct, I can simply go and substitute things in. So dx by dA is the reciprocal of this number 1 equation that I have. So it will be 1 over 2 pi x times dA by dt is what we have there, 0.032. Tidy that up a bit, so you have 0.032 divided by 2. So that gets us 0.0 0.016 over pi x. And we want to find out what dx by dt is when the radius of the rod is 2 centimeters. So now I'm going to go and substitute that in. Let's just check we've got the correct thing. Well, the radius, remember the radius is represented by x, as we can see here, so don't get confused. Radius is x, so we're going to substitute x is equal to 2 in there. 0.016 over pi lots of 2. So, and they want the answer to 3 significant figures, okay? So divided by 2 pi. And that should give us correct to 3 significant figures. That is 0.00255. Correct to 3 significant figures. And this is at x equals to 2. So that's part A answered. Part B goes on to say, find the rate of increase of the volume of the rod. Now, this bit here, so that's part A. Let's go and take a look at part B. Now, for part B, what we have to understand is that they haven't actually told us what differential to find. But the fact that they may mention rate means we want something which is changing with time, and it's rate of increase of volume. So what we want from here is we are after something which is changing with respect to time. It's the volume changing with time. So that's what they want us to find. And they want us to find dV by dt at x equals to 2. So let's go and write down what we're after. We're after dV by dt. I start off with looking at my numerator. Okay, so on my numerator, I've got dV, so I'm going to start by looking for one of my differentials that has dV in it. Ideally one which has dV on the numerator. Let's make sure I've got all of them. I got number 1 here boxed, dA by dx, number 2 which is dA by dt. And notice here I found something else there as part of part A. The answer was dx by dt. I actually found that. I'll label that number 3. Okay. Now I don't have anything with V in it. So what am I going to do? Well, I need to then go and actually form an equation for volume. Do I know anything from the context of the question that enables me to create an equation for volume mentioned, which will then get me a differential involving V? Well, we know that the volume of a cylinder is equal to cross-sectional area times the length. So I'm going to go in first of all, do that. So let's go and take a look at this. What do we do? The volume of the cylinder. I'll just make a note here. Should write it on here. So I'll come back to dV by dt. Let's just park that to the side. But let's go and focus on what the volume is. V is equal to pi times x squared, which is the cross-sectional area, times by 5x, okay, which gives us 5 pi x cubed is V. But from here we can find out what dV by dx is. I know the question's not asking for that, but this creates another differential that we can then potentially use later. So dV by dx is equal to 15 pi x squared. So this gives rise to a fourth differential that I could potentially use. Right, so I've got them all boxed and numbered. Let me go and use them. I want one with dV in it, and this is the one that I've actually got. So I'm going to write down first of all dV by dx. So that's using this equation number 4 here. I'll just make a note here, number 4. And then I want to get rid of dx from the denominator. So I'm looking for something that has dx in it. Okay, I'm looking for something that has dx in it and potentially dt, because look at my denominator on this. I want to end up with something that has dt on the denominator. So do I have something with dx on the numerator? So the dx's cancel and dt? Well, I've actually got that number 3 here, so I can go and use that straight away. So I only needed to use 2 in this case, 2 equations rather than 3 or 4. Okay, so that would work. So I've written that down. That would simplify to give us dv by dt as required. Get rid of that because we are obviously not cancelling them out, but let's go and write down what those things are. dv by dx is 15 pi x squared, and times by dx by dt, which we got earlier, is 0.016 over pi times x. Tidying that up a bit will give us 15 times 0.016 and divide by pi on both sides. Okay, so that gives us an x squared divided by x, simplifies to just that. So we end up with 6 over 25. If I times that all out, lots of x's. And we want to find out dv by dt when x is equal to 2. So now I can go and substitute dv by dt at x equals to 2 becomes 6 over 25, lots of 2. And we want our answer. It tells here, well, it doesn't specify how many significant figures, but if we type that in, that gets us 0.48. dv by dt is equal to that. What is this in terms of the units? Well, it's change of volume with respect to time. So volume is centimeter cubed per unit of time per second. Okay, so that's my final answer for that question. So there you have it. Question on rates of change using all the information, using chain rule and connecting different differentials to each other by looking at how to get the left-hand side of the equation to be the same as the right-hand side when we use chain rule.